Well, good afternoon, everybody. I'd like to welcome you to the first event of this week of Innovation 2015. And of course, we're really focusing this week on Mars exploration. It's an opportunity to step back from our day-to-day work and take some time to think about what we need to accomplish in order to explore Mars with humans, and give ourselves an opportunity to think differently about how we might go about doing this. You know, I've heard some people say that they don't have time to attend these innovation events or to innovate themselves, as if somehow it's not connected with our day-to-day mission. But in fact, what we are concentrating on this week has everything to do with our mission. And it's imperative that we are innovative and that we are being deliberate about how we choose to approach exploration if we're going to succeed in the future. So thank you for coming today, and I encourage you to participate in the other events this week. I think you know tomorrow Andy Weir will be here, the author of The Martian. On Wednesday, we have a chance to hear essentially elevator pitches from the people who have submitted projects for the Innovation Charge Account. That's at 11. There will also be a chance after that to do book signing with Andy Weir. On Thursday in here, we can learn more about some of our engineering and science efforts that will take us to Mars. There's going to be, these are kind of in the format of like TED Talks, but we can't call them TED Talks because those are like branded. So talkMARS, that's what those are going to be. One of them is going to be called Inflate Your Space, about inflatable structures. One's on landing humans on Mars, and one's on robotics as precursors to Mars. So hope to have you attend that as well. We're also going to be sending out or opening up some challenges this year. And the first one is going to launch this week, and you'll hear a little bit more about it during the week. But it's going to be aimed at identifying maybe hidden gaps in our Mars EVA systems and operations. So thinking about what we've already determined our gaps and how we're moving forward, but making sure there aren't other things that we need to be thinking about. But really all week, this is a chance to discuss and share how we engage all parts of JSC more collaboratively on our journey to Mars. So now I'd like to invite up Jeff Davis, Director of Human Health and Performance, who's going to introduce today's guest speaker.
Thanks, Ellen. And as part of what Human Health and Performance is doing this week, we are having a couple of days of blue sky events where we're really trying to think about disruptive innovation and what does that mean for us to get to Mars in the next 20 or 25 years. So to kick that off for us today, it's my pleasure to introduce Dr. Daniel Kraft. He and I have known each other over the last 25 years or so. And he has 20 years of experience in clinical practice, biomedical research, and healthcare innovation. He chairs the medicine track for Singularity University. Some of you are probably familiar with that. And is founding executive director of Exponential Medicine, a program which explores convergent, exponentially developing technologies and their potential in biomedicine and healthcare. His various TED Talks have over 1 million views. He was trained at Brown University, went to medical school at Stanford, and then attended the Harvard Combined Internal Medicine and Pediatrics Residency Program at the Mass General Hospital in Boston and the Boston Children's Hospital. He went on to complete Stanford fellowships in hematology and oncology and bone marrow transplantation, and has extensive research in stem cell biology and regenerative medicine. He has multiple publications in Nature and Science, and medical device, immunology, and stem cell-related patents through faculty positions with Stanford and as clinical faculty for the Pediatric Bone Marrow Transplantation Service at the University of California at San Francisco. So I think you'll enjoy this as a very diverse, interesting talk about what the future and potential of medicine can be. And with that, I'll turn it over to Dr. Daniel Kraft.
Thank you very much, Dr. Davis, and really appreciate the invitation to be here. It's amazing to be back at JSC. Some of the history that wasn't in my short bio is that I had a great workshop this morning, but I actually got to spend some time here in the past, not quite this far in the past, but I was a wee pup. I was at the Apollo 17 launch, and I was just home in DC at my parents' house and found some of my original elements from that. And just just a moment to thank all of you from the past and the future for the inspiration that's been in my life and many, many others that's been built right here at a JSC. Here's the best things I found in that old box, my old coloring book. And some match collection. Maybe that's worth something on eBay. I went on after being inspired as a kid and growing up near the Air and Space Museum to spend time at Stanford working on missions to Mars, and then actually spent a summer at International Space University, of which some in the crowd here are alumni and friends. We did a whole mission to Mars architecture, and so I spent some time thinking about the issues of long-duration spaceflight, everything from long-duration partial gravity on the way to Mars and back. But it really helped inspire my thinking as a physician and scientist about the convergence of technologies coming in different places. And even when I was a medical student at Stanford, I worked and published an article on venoconstructive thigh cuffs, and my co-author, some of you might recognize Kel, is Lindgren flying to space station in a month or two. So that's a little bit of my past. And I spent a month here as a medical student when I was at Stanford, even published something on on liquid cooling garments. And about 10 years ago, came here to interview for the astronaut corps. So I had a great experience then. Unfortunately, the dock got docked out. My left eye was just over the 2200 uncorrected version. So someone fix that for me, please. Okay. So let's look a little bit into the future of health and medicine in a broad perspective that might inform some of your thinking about as we go to Mars and beyond. And it's a bit fun to go back to the future before we go dive into the future. If you all remember, what year did they go into the future in this movie? It was 2015. We're actually in the future. I'm waiting for my hoverboard. It's under prototype, but it's Tony Hawk on a hoverboard prototype. But as we sort of look into the future, it's sometimes helpful to know where we came from. And I had a chance myself to go back to the future recently. I trained at Mass General Hospital. I was back there for the 200th anniversary of MGH. Those are the guys and girls I trained with in the trenches. And of course, it was in Boston, so we could joke about walking uphill both ways in the snow. And I found myself after one of the receptions all by myself at midnight in one of the most famous spots of healthcare history. It's called the Ether Dome, and it's called the Ether Dome because back in 1846, over 150 years ago, the patient in this very picture was the very first to get general anesthesia with his surgery. Before that, they used to literally bite the bullet. This picture is clearly before the HIPAA privacy laws came along. But if you go to the Ether Dome today, which you can go to, it's frozen in time. You still see the same actual sponge and the medical instruments from that actual case. Nothing has changed there. I wandered down the hall about 4 minutes away to the ward where I spent my first month as a terrified young intern doctor in 1996, and to my shock and dismay, that was also frozen in time and unchanged. Had some of the alarms beeping, some of the same nurses, some of the same patients. The only difference was the poor intern on call was pushing around this ancient laptop, had to type out the medical record, electronic version, and put it in the paper chart. And the front desk is using the cutting-edge medical communication technology of our day, the fax machine, right? So here we are at a great medical institution, still using fax machines, still thinking in many ways like 1846 and old silos and old ways of thinking, old departments and specialties, kind of the way medicine's been structured. But you know, we're in this new age where we don't need to think about our doctor visit being the 37-minute wait on average for the 12-minute on average doctor visit. We're in this connected age, this exponential age, where we can think out of the bucket of body parts and specialties in different ways. And I think the same thing applies for spaceflight. All these different technologies and fields, some old ways of thinking, some new ones that can come together to reinvent spaceflight and aerospace medicine. Because we have challenges, whether it's in space or on the ground. In medicine, lots of challenges: rising costs, the aging demographic, 10,000 baby boomers turning 65 every day, access to care. No matter what you think about Obamacare, we have a lot more covered Americans, but a big shortage of primary care physicians in many parts of the world, let alone on other planets. We have issues with big data coming at us, lots of data like you deal with, but how do we make that insightful and actionable information that you can use as a patient, as a consumer, as a physician? And a lot of that care, as you might know, is fragmented, still sometimes on paper, sometimes electronic. So lots of waste in the system. And even though a lot of the innovations are here today, the technology is here today, I'll show you some of it, our friends at the FDA have problems regulating it. Our friends, the payers who cover the costs, don't know how to often pay for these things, similar to the challenges of flying certain hardware. So if we think about our healthcare system today, it's really a bit of a sick care system. It's built on a very intermittent and reactive model. Intermittent meaning every once in a while you get a piece of data, blood pressure, EKG, a cholesterol level, and the data you might get to your doctor occasionally, very intermittently. And we're very reactive. We wait for the heart attack, the stroke, the lump to be stage 3 and detected. What if we could use technology and new technology and new thinking to be much more proactive and continuous with our healthcare? And that's the promise of technology. Another promise is to shift us from the sick care system, where we spend 80% of our healthcare dollar on folks who already have chronic disease, and instead of doing sort of what we call reimbursement-based medicine, we can do more real evidence-based medicine and proactive preventative. And we can use technology today for ourselves and our friends and family to stay on the left side of the curve and not get those acute and chronic diseases in the first place. So that means we need to shift the incentives, but we're also shifting where healthcare happens. It used to only be in the clinic and the hospital, but increasingly healthcare is coming to our homes, onto our bodies, and as has been pioneered here, off the planet. So where healthcare happens can really change, including your corner Walmart or CVS or Walgreens. All of them want to be your primary care doctor in a sense, and you'll see more of that happen in the next few years. So let's take a step back and realize how fast the world is really moving today. I came back to Stanford to do fellowships in hematology oncology about 10, 12 years ago, and so much has happened even in the last decade. It was only 2001 that the first iPod came out. I thought it was like 1991. It's only 2001. That feels like not so long ago. And if you think about Apple and what's changed with that company, they didn't invent the MP3 player or digital music. They put it together in smart, impactful ways. That's changed the Apple's business model. And Apple has been riding this exponential technology trend. What used to fit on an iMac of 2000 now fits on your iPhone, and as of this week fits on an Apple Watch, right? And this is an example, and of course the computers are getting even smaller. That's the size of a grain of sand that probably has almost as much computational ability as what Apollo flew on a grain of sand size technology. We have really an ability now to think exponentially. The speed and power and computing of this little smartphone, this is an antique now, this is an iPhone 1. It still works, but it would feel antique. Remember, smartphones have only been out for 7 years. It's riding Moore's Law. Moore's Law was 50 years old as of a week ago, and it's an example of an exponential technology, doubling in computing power every 2 years or so. And our brains think linearly, 30 linear steps, I'll be to the exit, but 30 exponential steps, doubling, 2, 4, 8, 16, 32, 64. By 15 steps, I'm at 30,000, but by the 30th step, I'm at 1 billion. That's 26 times, in orbit around the around the planet. And that's what we need to do in terms of health, medicine, and aviation, is to think exponentially. That's where the disruptive opportunities come from that we can use to reinvent and reimagine the world. And of course, it's not just Moore's Law, it's 3D printing, it's robotics, it's social networks. All these things are coming together really in interesting ways to enable us to reimagine things. Just like in the last decade, we've reimagined how we read books. We sell more ebooks than regular books. Amazon does. They've self-disrupted. We've seen other companies go bust, like Kodak had their Kodak moment. They actually invented digital photography, but didn't pay attention to the curve of exponential, so they were bankrupt. And Instagram sold for $1 billion, 12 kids down the street from me in Palo Alto. When was the last time you went to a Blockbuster? They've gone bust. They weren't paying attention to exponentials in terms of data. Any folks here use Uber, right? Uber is now a 4 or 5-year-old company worth over $40 billion. They did not invent any of the technology used, the smartphone, online GPS, mapping, payments, but they bundled it up in a smart way to now disrupt the limo and the cab world to the point where there's now the folks who are being disrupted, like in the taxi drivers in Berlin, have a protest about it. And it's been outlawed in Germany. But that's an example of leveraging technologies together. In fact, yeah, I was in Vegas, and the mafia there, I guess, doesn't like it either. But I asked the question, how can you build the Uber of healthcare or even of manned spaceflight? I asked the question about medicine, and 3 companies said, we've already built the Uber for healthcare. You download the app, you press a button, and a doctor comes to your house or apartment within 3 hours, at least in New York. Not sure what kind of doctor, but you get a doctor. And remember that they can rate you and you can rate them, so there's a transparency element. And even Uber did their own little pilot called Uber Health, where you'd slide the thing to the right, and an Uber would come with a nurse and give you your flu vaccine. So that kind of seamlessness of access, knowing where the car is, the payments, is an example of the world shifting and where folks want technology to take them. So disruption's all around us. It's happening in major industries, including spaceflight. And I would encourage you to be the disruptor, not the disruptee, and to start thinking exponentially. So we'll cover that as we go into the present day, into the future. And many of the elements from healthcare, remember, apply to many elements, I think, of particularly of manned spaceflight. So let's look at some exponentials at play. The human genome. It was only about 12 years ago that the first genome was sequenced. It cost billions of dollars, took several years. The price and speed of sequencing your own genome has dropped at twice the rate of Moore's Law to it's about $1,000 today and can be done in a year. In a couple of years, it'd be $100 and less than the price of most x-rays and other lab tests. Some of you might have done 23andMe and other ways of accessing your genetic information. There's lots of information there today for $100. The trick is what happens when you come to your doctor with your genome on a disk drive. They don't know what to do with this information. It needs to be part of the workflow. Just like many of you access a lot of information, it needs to be part of how you see it, how you make sense of it. But we can already do things with our pharmacogenetics. This is from a $100 test. Here's my genes for a blood thinner. Here's 18 of my different drugs that might be affected by my genes. That information's here now. I would encourage you to even try some of these consumer genetic testing elements. You may learn something about yourself that might be useful. In fact, I uploaded my genetic data, and I could look at this is called athlete. They look at your athletic genes. And I can see I was always a good sprinter, never a good endurance runner. And I didn't quite get up for the gym this morning, but I have an excuse. My genes for motivation are low. So I got an excuse there. But as we look at long-duration space missions and others, we'll maybe even tune people's understanding who's genetically most adaptable for long-duration missions and others, which is one example in that world. And it goes well beyond the genome today. There's all these omics, the proteome. You can get 10,000 biomarkers from a drop of blood. There's the exposome, where you've lived. If you spent a year on space station or lived on a farm in Idaho or by 3 Mile Canal, you have different exposures, radiation, cancer risks, others. Our cell phones know where we live. They can measure that. There's the idea of the microbiome. We are made up of 10 times more bacterial cells than human cells. And it turns out the microbiome, particularly in our gut, can play a really important role in everything from obesity to inflammatory bowel disease to psychiatric disorders. About 14,000 Americans die every year from infections in the hospital. And now we're learning at my old home base to do fecal transplants. Not too sexy, but it's going to be part of the therapies of the future where you take a microbiome cocktail to maybe replace and augment the one you have. So that's not science fiction. That's coming along. And that's just one of several ohms. So we all want personalized medicine and precision medicine. It's often best, I think, in terms of systems medicine. This idea that it will be predictive, will be sequenced at birth or sometimes even before birth. That's possible now. From a mother's blood, you can sequence the entire child. We can then take preventative steps that are more personalized. And the final P, I'll challenge all of you, is to be participatory, to share your own data when it's realistic to do so, to all become part of the future of health and medicine by becoming data donors as we move forward. So another few exponentials at play. Imaging. Imaging now is incredible. A lot of this is spun off, by the way, from NASA-based technologies. We can see inside the body with incredible resolution, and your surgeon or your interventional radiologist can now find the tumor and avoid the blood vessel. That's all done on a tablet computer and reconstructed in real time. The world of neuroscience is really getting shaken up. We can not only appreciate the amazing anatomy of our brains, but what's often called the connectome. How are we wired? Has it play a role in everything from autism to Alzheimer's? And speaking of being proactive, Alzheimer's, we know a major challenge. What if we, instead of waiting for it to happen and not having much to do, we could pick it up early? Well, there's now some types of scans where we can scan a patient and find that they're going to likely to become an Alzheimer's patient 10 years later. Or, as published last year, blood-based biomarkers, or even visual eye tracking tests you can do with a $100 laptop and an eye tracker that can predict whether someone's going to develop Alzheimer's. And as of last month, there's now a new drug that looks like it's coming along that can reverse or stop plaques. So maybe we'll identify folks early and then give them some of these therapeutics before they ever develop symptoms, what I like to call stage 0 medicine. That's just one example. Another area set to shift is cardiovascular medicine, the #1 killer. What if, instead of doing the cardiac angiogram, which takes dye and a catheter up the groin, you could do computationally a 30-second CT scan, send that data to the cloud, and now computationally characterize, is your blood vessel narrow or not? How narrow? Does that patient need a stent or a bypass? What kind of stent? What size? Maybe we'll even 3D print that stent for that patient in real time in the future. All that's now being blended from the convergence of imaging, cloud-based computation, and mathematics. A lot of this was actually done from NASA Ames-based fluidics technology, and now it's translating, and this was just FDA approved last month, and I think will be replacing some of our angiograms in the next year. Or a company I advise called Morpheus, they can do a 4-minute cardiac MRI, completely reconstruct the anatomy of your chest and all the functions of your heart, kind of like an echo. And this will be faster, cheaper, and give us much higher resolution personalized data. So a few examples of convergent technologies coming along. But probably the most disruptive technology in the future of health medicine is you, the individual, the consumer, the patient, where we're all now, this is the old school technology. 10 years ago, I had a Palm Pilot. That was fancy. And of course, now we're in the smartphone era. And now at Stanford, my medical school, every medical student gets an iPad their first day of school with their entire curriculum on it. You're flying tablets now to ISS and beyond. That's changing the game for medicine. Almost every doc brings their own device to work. I was just in India. They now have $35 Android tablets on sale. For $35, that's going to democratize everything from education to public health and beyond. And in a few years, the poorest on the planet, you remember 80% of the planet today has SMS phones, even the poorest billion individuals. Soon they're going to have the equivalent of our fancy smartphones. That can really change things, including in healthcare. And it's meaning technology is sort of disappearing. That used to be $100,000 of different technologies. Now it's essentially free. You don't buy a GPS device anymore. You download it on your phone, even the flashlight's in your phone. So we're starting to have technology disappear, and in some cases get cheaper, better, and more functional. Even Google, in their new smartphone, it's modular, so you can put in different modules if you're a diabetic or need to track your EKG. So the new drug is really you, the empowered patient, to own your information, to say, I'm the CEO of my own health. If you have diabetes, you can now get connected glucometers that will record your blood sugar, send that to your clinical team. There are now patches that can transmit to your smartphone real-time blood glucose. And if you are diabetic and you have a dashboard of your own data, you can be much more on top of your care, and your physician as well. This is a simple app that they published a few years ago and studied. They were able to lower the average hemoglobin A1C in diabetic patients by 2 percentage points just with the app and changing diet and tweaking the meds a bit. This is now the first FDA-approved app that's getting paid for by insurance companies for diabetes. So we're going to enter an era where I'll prescribe you not a glucometer, but a glucometer with the social network in it and diet tracking and a team. I'll be prescribing you apps instead of a drug and device, apps for pregnancy. Pregnancy hasn't changed for a while. Pre-op apps, post-op apps. All these things are going to become embedded in our everyday health and medicine. And just like I think you can send up checklists now by apps, that sort of element will come along. You can now make restaurant reservations, like with OpenTable. Another company did that for doctors. ZocDoc, one of the most successful healthcare IT companies, bringing that sensibility along. Even the pharmacies now allow you to scan your pill bottle and do a refill. So this new appification of medicine is quite powerful. They're coming to our Apple Watches to remind you to take your meds, which is important because 50% of folks don't take their medicines as they should, and you might have now an easier reminder. We're seeing Mayo Clinic publish that apps can reduce hospital readmissions dramatically. So the lesson here is it's this integration of information, technology, and mobile that can really empower all of us, whether you're a physician, a patient, a flight surgeon, or what have you. And we can make healthcare more engaging. What if we make, some people like points. Some of you have Fitbits and compete with those technologies. We can take off-the-shelf technologies like a Microsoft Kinect that used to be, millions of dollars, now is consumerized, and that can be used to help you track your physical therapy, make it more engaging and fun. Maybe folks will actually do it for a change, right? We can now digitize all this information. This new era is often called mobile health or connected health or digital health, because now in my pocket I can have the equivalent of an entire clinic in the past. I can attach to my smartphone a little otoscope and look in my kids' ears and send that data back and prescribe that to families with kids with otitis media. Or eye exams, and I know NASA's work with iNetra to do eye exams on your smartphone. Their first market was in the US actually, or NASA. They were going to go to India, where you could have very few eye doctors, press a button and order your glasses. And as of last week, this company spun off a different one called Blink, where in New York, a little team will come in a car like an Uber and do your whole eye exam with these mobile devices and send you your glasses or contacts. So new ways of bundling things are shifting entire industries. One of my favorite examples is telemedicine was really invented here. I mean, here's Buzz Aldrin's, or Buzz Aldrin's EKG. When he landed on the moon on Apollo 11, he had a very fast heart rate. I think Neil was a little more chill. But you were able to transmit an EKG from the moon. Why can't we do that on Earth? Well, finally, you sort of can. There's now a technology I have in my pocket. I'll do the live demo. A little smartphone case costs, $10. And it's going to stream an EKG directly on my phone. I just hold this on my case. I won't do the live demo right here, but it looks like this. We could pass this around the room and probably detect people who have a heart issue. Or if someone collapses at a party, it's a great party gift. You can diagnose things. Or if someone has atrial fibrillation, or you're on station and someone has a funny rhythm, you don't need to wire them up with 12 EKGs. Say, hold the phone, boom. That data is available immediately. And the app itself now does analysis, or you can press a button and have an actual cardiologist see that data. So the ability to collect information and gain insights for it, here's my EKG on this, is particularly getting faster, cheaper, and easier. Now, some of this came from this consumer movement, often called the quantified self, only about 6 years old. How many folks here have a Fitbit or any kind of self-tracker? Only a few of you. I probably lost it in the laundry or forgot the charger. Well, I'm wearing like 6 of them right now. I won't show them all of them. But that world now where we can connect our scales that can tweet your weight, blood pressure cuffs that talk to each other, our smartphones now, right? These are highly instrumented devices that can track your heart rate, your steps, other elements. Blood pressure. Some of you might have high blood pressure. You can now, for $60, buy a connected blood pressure cuff and integrate that data back to your doctor, because companies like Google and Samsung and Apple are now integrating that through your consumer devices. So now that information can seamlessly flow and potentially become actionable, not just another data point. Oh, by the way, you can have this data. Sometimes you might need a coach to help you. There's now coaching apps where you have a real coach, but we're moving to the era of AI coaches. Here's a quick look of something coming soon.
Meet the world's first artificial intelligence personal robot. She's your welcome friend at any hour.
Good morning, Thomas. Time to get up.
Good morning.
It seems like you had a good night's sleep. 8 full hours and a good resting heart rate.
Thank you.
Your meeting with Jane is at 9:30. I put the coffee on.
She can interface with household devices. And she's also a personal stylist.
What do you think?
Why don't you try the blue tie with it?
Good idea.
She's your world-class office assistant, using our
Yeah, that's coming along, a little AI assistant. We can even wire our youngest patients. This is my son Leo about 6 months ago when he's wearing a connected onesie. So he's donating his data to science, and I don't need that to tell him he's waking up every 2 hours. But what if you had a child in a neonatal intensive care unit? You could send them out earlier with some of these connected technologies. And some of them used to be, very futuristic. This is from the cover of Wired, the back page, Artifacts from the Future, the connected diaper. Well, now, as of last year, Huggies came out with TweetPea. You can figure out what that does, right? There's also data for number 2. Sometimes too much information. It's available. All right, okay. Other ways to get connected now. These sensors are pretty basic. They're little accelerometers. Used to be $1 million accelerometers, are now $2 and can live in all of our devices. So we're moving to all this Internet of Things. It's coming to the Internet of the body. Internet of Pills. There are pills now that can track when and if you took them or not, right? There are now patches and clothes that are being embedded with wearable devices. And when the astronauts fly, they're very telemetered, but these now come from a simple take-on shirt. They're going to be part of our cars. Digital tattoos have been developed that can monitor and track your vital signs. I have in my pocket from a company, oh no, technology fail. Let's see. This sometimes happens on this. It's okay, I got to back up. We've seen now companies like this little patch I'll show you in a second are able to, let's see. Let me get out of this for 1 second. We're seeing technologies like this smart patch, I'll show you in a second, if I can reboot this, are really able now to stream what used to be intensive care unit level data right to our smartphone and into the cloud. This would be something we're talking about this morning that could be flown on station today or in future missions, whereby you're able to have what's essentially used to be an intensive care unit just with this little patch. This little patch is going to be about $3 a day, and you'll soon be able to wear this for sporting, to optimize your activities, but also be useful in a whole new realm of activities to track and learn from. So we have billions of data points coming from our mobile devices. The challenge is, what do we do with this? How do we make sense of all this information? You want to be overwhelmed by 12 apps and 12 different devices. So my favorite analogy would be the modern car. Your modern car today has 300 sensors in it. You don't care about any one sensor. You care about when your check engine light comes on. And when your check engine light comes on, hopefully you do something about it. Just like when you have master warning switches on shuttle or station, you're able to make sense of those things in a proactive way. So I think as we take this data into the future, and this is what the streaming data looks like. Sorry for the technology issue here. This is what this data looks like streaming from that little patch. And that can be done and probably flown tomorrow with the right approvals. We're going from wearables to insidables, contact lenses that Google has developed. Google has developed contact lenses that can track your blood sugar, and they partner with Big Pharma to bring that to market. There's pills you can swallow that will replace an upper endoscopy. So the way we can collect data is changing. And there's thousands of these on the market now. I encourage you just to try one that you don't ideally lose, and start to gain insights about your activity, your sleep. That can really be one of the most proactive things you do. And that goes well beyond our vital signs. Now our blood work. We can now shrink a laboratory onto a chip, this world of microfluidics. A single drop of blood now can give you 100,000 biomarkers potentially, and that can be done for pennies on the dollar. We now have the ability to do what I often call a blood biopsy. I'm an oncologist. If we can get a biopsy of your blood instead of the tissue, we can pick up disease early and treat it in smarter ways. Even simple things like a urinalysis. You know, a urinalysis strip, you look at it, that can be appified. Here on the left, you see a little dipstick with a QR code. You dip it in the urine, and you take a picture with your smartphone, and it sends the data immediately up to your clinician, to the CDC, to the NSA, whoever wants the data, all right? Or it's flu season, right? Flu season, you spit in a tube and the lines show up kind of like a pregnancy test. You take a picture of the app, it can diagnose your respiratory infection, whether it's influenza or maybe Ebola. And speaking of things like Ebola, we can even now print at the point of care lab tests, which might be useful on long duration or on station. You can print the lab test on demand, in this case one developed by Harvard to pick up Ebola from saliva. So lots of ways to get this data now, and the implications are we can help stem pandemic disease by blending information. We can essentially do what you've been doing in orbit for a long time, a digital checkup. You can pick up the vital sign information, you can pick up the lab data, you can communicate not with the flight doc, but you're actually your own physician. There's now a whole slew of apps you can download and do a telemedicine visit. And so we're really going to enter an era where you're going to be able to connect in new, empowering ways and bring smarter, less expensive, and more proactive healthcare. And ideally, remember, technology is just an enabler. I don't think we can't scale empathy. This is all just to hopefully enable your own health and the patient-doctor relationship and beyond. Ideally, this technology gets out of the way and makes these things much more streamlined. Medical trials, drug trials, for example, are still a big issue. It takes $1 billion, 10 years, half the drugs fail. What if I could push you an app with an actual trial on it? Maybe it's for Parkinson's, and I could use one of these trackers to track the shaking. Well, UCSF, one of my institutions, has developed a platform for cardiac disease on a smartphone. And then 2 months ago, Apple came out with ResearchKit. You today can go down on, if you have an Apple phone, and download clinical trials for heart disease, Parkinson's, asthma, and be part of a clinical trial just by downloading that on your smartphone. New ways of engaging and empowering and connecting clinical trials. This is my device. This is the app I downloaded for cardiac. They signed up 5,000 patients in their very first day. It would have taken a year to do otherwise, and it almost was free. So think about the democratization there. And just briefly, when we think about medicine and therapy, we're going to go beyond pills. We're now entering the real era of gene therapy, where we can start to actually correct a gene, like for sickle cell or thalassemia, and have long-term cures. So that's coming into the clinic now, and in 5 years will be, I think, quite commonplace. So part of the lesson here, as you start to think exponentially and convergently, it's a layering of technologies. That has challenges. The new pacemakers are smaller, easier to implant, and they all have IP addresses. So what happens when someone hacks your pacemaker or your insulin pump or publishes your DNA from the cup that you had for lunch, right? Interesting implications there. Who owns the data from our own bodies? Sometimes the companies who make the devices don't give that data away. So really interesting challenges there. One of the other challenges is there's just massive amount of data. How do we make sense of it? Our brains haven't had an upgrade, but our technology and our spacecraft getting upgraded. So we need new tools to improve our cognition and our ability to make sense of this. And that is already here. AI, artificial intelligence. Some of you might remember IBM Watson beating the champions of Jeopardy. Didn't just beat them, it really beat them. That was 3 years ago. IBM Watson has now gone to medical school. And that threatens some doctors. Like, oh, a robot AI is going to take over. So I like to reframe it not as AI, but as IA, intelligence augmentation. And that is going to infuse everything we do, from complex missions to how we staff a hospital, how we do diagnostics, how we pick the right therapy. And we can connect to Watson now through our mobile devices. So soon you're going to have like Siri blended with Watson on your smartphone. In fact, IBM, Apple, and Medtronic announced a partnership last week where they're going to blend these together. So it's a really powerful time. And the lessons from AI, I think, certainly apply to all the complex missions that you guys build. So here's that check engine light idea. I think kind of like the GE cars have the OnStar for the body, I think we're going to have our own check engine lights, our own sort of OnStar that can help let us know when to be proactive and be connected. So where does this come together? A lot of it's been inspired by the space world, and some Trekkies here, I'm sure, right? Remember the Bones McCoy with the tricorder? That used to be science fiction, but now there are $100,000 ultrasounds that fit in your pocket and do the same thing, right? We've seen now, I'm sure many of you know the X Prize. Peter Diamandis co-founded that sent Spaceship One up to space about 10, 11 years ago. There's now an X Prize I've been helping with called a medical tricorder X Prize, a $10 million prize to bring folks together to build an actual medical tricorder. And one of the teams started at Singularity University. This is actually it, right here. This is a device you hold it to your forehead as the patient at home, and it collects your heart rate, your temperature, oxygen saturation, your blood pressure. It calculates it. It understands your baseline. It'll communicate that to your clinician. And what's interesting about this is they crowdfunded this, like $1.6 million, and 10,000 of these shipped in the last month or so as part of the trial. So in a year or two, I expect you'll have something like this in your own home, which will help you track your own information. And this has design thinking built in. I introduced this company to IDEO, and we made this little movie of the near future of all these technologies coming together. Take a quick look.
Technology has given us an unprecedented window into the human body. But on a day-to-day basis, we're still in the dark about our own health. We are changing that.
You okay? Do you feel okay?
What if instead of fearing the worst when you notice something out of the ordinary, you could identify the condition yourself? Getting the right diagnosis would save you worry
It says it's roseola.
and an unnecessary doctor's visit.
Rest at home. It's okay.
Instead of hearing about a viral outbreak on the news, imagine you got an alert that was tailored to your family's needs. It would also give you advice about what to do next. What if you had a way to identify what was wrong right away?
It says it's 103.8.
A way to get all of the information you need to understand the situation. And in serious cases, you would know when and where to seek help.
Yeah, it recommends taking it to the urgent care.
We're building a way for people to check their bodies as often as they check their email. It's all possible, and it's only the beginning.
But this technology is coming for those who like to measure your data. And in fact, again, they funded this. They crowdfunded the clinical trial for this. So new ways of funding innovation are here as well. And that means we're all not just silos, we're not individuals, we're all part of a connected system. Whether you're part of a crew or a family or a community, our social networks play a huge role in our health, whether it's depression or obesity. And we're learning that our behaviors are much more impactful than our baseline genetics. If we can moderate our behaviors, we can have a huge impact on our costs of care, for example. And there are new ways to do that. If you're pre-diabetic and you're discovering you're about to become a diabetic and have a lot of costly and expensive medical issues, you can now download an app called Amada Health and be part of a social network and learn to turn around pre-diabetes so you're not diabetic anymore. That's a new way of prescribing behavior change. Or what if you could see future you? You look in the mirror and you see future you, right? That's going to inspire some folks that might rewire your brain. Or if you keep having donuts for breakfast, future you, right? That might inspire you. And you don't need to wait for the magic mirror. You can download an app. Here's me now. Here's me 1,000 donuts later. Future me, you know. So I vote the donut. Or if you have a kid or a patient who smokes 2 packs a day, you can show them what their skin's going to look like. That might change your perceptions. Or if you're spending too much time on Facebook, you know, lots of ways to see the future. Including now this amazing world of augmented reality. You know, many of the astronauts are training with augmented reality. That's that company was acquired for $3 billion. And Google said, we can build one of those for $10. This is the cardboard-based version. You slot your smartphone and you're in a virtual world. That can do everything from training on missions and maintaining currency on spaceflight, to learning anatomy, to treating PTSD, to being in all sorts of new environments. We're going to see a lot happen with augmented and virtual reality, especially in healthcare, and especially as you want situational awareness if you're a pilot, a physician, a surgeon, or a patient. Think about how that's going to integrate in your lives. And we can be telepresent as well, not just with wearables, but telepresent robotics. We can already round in hospitals with special robots. I was actually on a panel, meet Dr. Droid. I couldn't be there in person, so I showed up on the left in the panel on the robot. New ways to be telepresently localized. You guys do all that already in orbit, but that's going to change healthcare. We have robots delivering labs and x-rays in hospitals. We have robots enabling the disabled. One of the most exciting areas now is enabling the disabled with things like brain-computer interface. This is my alma mater, Brown University's work. A small chip on the motor cortex of a woman who's quadriplegic, can't move from the neck down, just enables her now to think, and she's able now to control a drink of give herself her first coffee in 16 years. That's transformative, and we're going to see brain-computer interface completely change how the disabled get around, and also enable us, super enable us. Maybe the folks, when they're on Mars, will have a chip on their brain which will enable them to control things. This is coming, and this also blends with health and prevention. Yoga, meditation, ancient practices can be really good for you. What if we can now use brain-computer interface to track that for yourself? Well, you don't need to have a version like that. You can now buy one for $200. Wear this headset. It can track your brain waves. Here's my mind being calm for a few minutes, actually. We could prescribe meditation or mindfulness. That can lower depression or anxiety. It might be useful on long-duration missions. All sorts of ways you might think about using these in your daily life. It's even being used to train kids who have attention deficit disorder to get focused. They learn to focus with a headset, and when they're done, they get off of their Ritalin and other medications. And we're even learning to use video games for good. Changing your wiring of your brain using gaming and headsets are going to be shown to be very beneficial in many modalities. All right, wearable robotics, and robotics has been used in the space program for years, but now it's coming to the disabled to enable someone who's paralyzed to walk. In this case, you have a woman who's wearing an exoskeleton, and she's able to walk. And what's really interesting about that is part of that is 3D printed to match her own personalized anatomy. So we're going to see a lot of changes, not just in treating spinal cord injury with robots. What about curing it? My field is stem cells and regenerative medicine. The gentleman on my left there won the Nobel Prize 2 years ago. Now we can take a skin cell and reprogram that to be your own pluripotent stem cell. And we're blending stem cell biology with the world of 3D printing, something many of you work with all the time. But 3D printing is actually starting to impact healthcare in powerful ways, from neurosurgical devices to making a prosthetic limb that matches the missing leg, to making braces and crutches that might match your own arm. Here I have a little 3D printed brace for my hand, for example, that can be printed out at the point of care. We're seeing them for scoliosis. We're seeing them make new knee and hip implants that completely match the patient's anatomy. We can see them being used for surgical planning and actual surgeries. And you can even take something like a Microsoft Kinect and print yourself. I've got Mini-Me in my pocket. He's kind of cute and small, doesn't eat much. But what if I have a patient who's lost part of his face from cancer? We can make a prosthetic that matches. So really powerful ways are moving there. And I was just at the TED conference, and they announced their mode of doing that 100 to 1,000 times faster in terms of printing actual objects. So watch that space. We'll be on station or on Mars and able to press a button and really print something within minutes. This is a bit of a sped up version, but this is coming really quickly and is disrupting even the 3D printing industry itself. All right. And we're going to blend 3D printing with tissue biology, whether it's the early days of making tracheas and bladders, all the way to making more complex organs like kidneys, livers, and hearts, which are in the early stages today, but might be in the clinic within 10 years. So why am I talking to you as a former NASA JSC medical student and hem-onc bone marrow transplant doctor? Well, I've been chairing the medicine track at Singularity University since it started in 2009. We bring amazing folks together to cross-train in medicine, biotech, robotics, AI, 3D printing, space, and beyond. Co-founded by Peter DeMantis from XPRIZE and Ray Kurzweil, who's now the director of engineering at Google. Our head of faculty for the first few years was astronaut physician Dan Barry, who some of you might remember. Great guy, still involved in our faculty. And we start to ask the question, how do you take these technologies to address grand challenges in space exploration, energy, poverty, global health? And we've had some amazing innovations come from using drones to deliver drugs and vaccines. They're already now doing this, piloting this in the developing world. And speaking of drones, you can have one in your pocket now, right? There are drones that are being delivering defibrillators. Even in San Francisco, there's a company that wants to deliver your drugs by drone. Not sure what kind of drugs in San Francisco, but they're delivered by drone. Drones in your pocket. So lots is happening there, from telepresent gloves and beyond. And because 3D printing is interesting, one of our student teams from 3 years ago flew with you guys and made in space. Just this fall, the first 3D printer went to space station, and I think that has amazing implications, including one of our other colleagues was the first to 3D print on the ground medical instruments. So what if you have a medical case on station or beyond, and you can print devices, medical devices on demand? I think that's coming, and that's something that came out of Singularity University. So because so many folks were interested in healthcare and the blending of technologies, I put together a program called Exponential Medicine. We have it every fall. Now it's at the Hotel Del Coronado. Please come join us. Exponentialmedicine.com is the website. And it's that thinking now of different technologies, thinking exponentially, thinking convergently, that helps bring us to this future, right? And it's new thinking. It's not just docs and drug device people. It's robotics folks. All you folks have amazing skills that might be applied to spaceflight, but also applied to healthcare. So I encourage you to get involved in hackathons and startup incubators and bring folks here from other worlds to help you innovate the future of spaceflight. Even designers play a role, right? Design thinking can infuse everything from how you design a cane to the future of a hospital room to the future of a crew cabin. All that requires new integrative thinking. And since I've been a pilot since college, I love the idea of lessons from aviation and spaceflight applied to healthcare. Because if you fly on Virgin America, it's a different experience than others. That's the design of the whole flight experience. And thanks to one of the former flight surgeons here, Pat McGinnis, I joined the Air National Guard as a flight surgeon when I was a resident at Mass General. And what I learned there is technology sometimes fails us. But I joined the Air National Guard as a flight surgeon. I've had some amazing experiences flying in F-16s and F-15s, and the lessons from there are powerful, right? Many of you have developed them yourself. Here's some just fun flying photos. But lessons from aviation and medicine. So one of them that you all use every day are checklists. Checklists have now transformed the operating room. We don't cut off the wrong leg, which has happened, right? Whether they're checklists on shuttle or checklists for a patient, this is changing the way we do healthcare. And those checklists can now be personalized and tuned to the individual, to you. You can have your own personal checklist. We're seeing lessons from simulation, something you guys do really well and has made spaceflight safer, is now coming to the operating room. And every medical student now trains on, not cadavers, but on simulation. This is the Sim Center at Stanford, here we go. And now we bring teams together, just like you bring crews together, to train on procedures and dramatically improves outcomes. We can even simulate organs on chips. Couple last lessons, I've got 2 minutes left, is heads-up display. How do we see data differently? You know the old round dials. Now we're in the glass cockpit era. That gives the pilot and the crew situational awareness. How do we bring situational awareness to the intensive care unit? Lockheed Martin, the fighter pilot company, is working with Hopkins to make the new intensive care unit. How do we take the heads-up display of the flying world and bring it down? And how do we bring the other clues, like Bitching Bob or Bitching Betty tells you to pull up when you're about to hit a mountain? Altitude. Right? Altitude. How do we bring that sensibility to our healthcare? Because we need different data if we're landing in bad weather or we're in a dogfight. And we have dashboards already that influence our behavior. In some of our cars, we can drive to hit the right speed and element. And we want our own personal GPS to be like, Daniel, go right to the gym, not left at McDonald's. All right? That's going to come. You're going to have a GPS that's going to help guide you through your life based on your own information. Not too much data. Starbucks, squirrels, will be a little overwhelmed. You need to tune that to the individual as we go. And we're going to see the world differently. We're already in the era of basically bionic eyes. But even those of us who are lucky to see normally, we're going to see augmented vision contact lenses that can bring the internet to our eyeball, which also has a dark side, some interesting applications. Here's a vision of the future. You have a contact lens on, and you're on a tough date, so you bring up some little help. You need the Wingman app. Here we go. You can figure out what that does. So there's always a dark side of these technologies. But these sorts of ways of seeing the world differently are already transforming healthcare. Google Glass has had a bit of a bad rap, but one of its best applications, and this is still like a version 1.0, remember, is in healthcare. So your doctor can know you and some more information about you when they see them. Or the surgeon can have the right information as they're operating on you. Or the anesthesiologist has vital sign data. Sort of this heads-up display in our environment can be used in all sorts of ways. And this, again, this is the very early days of this sort of technology. We're going to see it become ubiquitous to the point where you see your breakfast in one way, maybe you see it in a different way, and maybe a little warning before you dive in.
Pull up, pull up, pull up, pull up.
All right. Last example will be radar. When we fly, we're on air traffic control. We know where all the airplanes are. What if you knew where all the patients were like you, or if part of a clinical trial? What if we could crowdsource our medical data just like we crowdsource our driving data? You give up a little privacy when you drive with Google, by the way. They know your speed and location. And from that, you can build, in this case, a map of Rome. This is Waze. This is just from driver data. And you now know the best route to work, how to avoid the traffic. That's crowdsourced information. I think we can apply that same thinking health, medicine, and even the future spaceflight, crowdsourcing the wisdom of the crowd, and change us from this era of flying seat of the pants, where we have limited data, we're practicing medicine, it's the art of medicine, where we can use all these new technologies and bring them together in smart ways. Even our social networks can give us clues as to who's healthy and who's not healthy in what particular neighborhood, just by people's Google searches or their social network data. And believe it or not, you can mine Facebook now and say, who might you want to avoid shaking hands with that day? That data's there, just not accessible quite yet. So just like you have dashboards in many of your day-to-day jobs, we're going to have dashboards for our health, for our entire life missions. That can apply, obviously, to the aviation space world. We can take these wearable devices now and crowdsource data. This is a wearable jawbone. And we can tell, near an earthquake, this was in Napa last summer, who woke up. The folks near the earthquake woke up. You can tell that. You can tell from this crowdsourced data where folks go to sleep and what time on average. So new ways of gathering information and being more proactive and hitting disease and picking it up before it becomes a problem. So I would encourage you to start thinking in a contextual form. You already do that with spaceflight, in terms of systems, in terms of design thinking as we go, and thinking exponentially, layering these technologies together, and thinking about how they overlap. And as we invent the future, don't just think about technology today, move to where it's going to be. And if we do that, we can move from this era where we've been stuck in healthcare since 1846 or beyond, very episodic and reactive, to one that's much more continual and proactive. And you can all start doing that today with your own health and that of your friends and family. And I think as you think into the future of spaceflight, these lessons apply, whether it's being an organ or blood donor and being a data donor, sharing data between ESA and NASA and others, how we can think differently about not just the overlap, but looking at to where the puck is going, the Wayne Gretzky quote, skate to where the puck is going to be. As you're designing systems for 2020, take a look at the trend of where Moore's Law will take smartphones and mobile. And I would encourage all of us again then to start thinking exponentially in the context of integration and realize that, like with many of the technologies in my pocket, they're actually already here. They're just not evenly distributed. And it's up to us, whether it's the future of space or medicine, not to just predict the future, but go out there and create it together. So with that, huge thanks. A real honor to be here. I'm happy to help out in any ways with anything you're doing in the future. You can reach me through that email or download my ask for the presentation. And thanks and Godspeed. Do you want to do Q&A?
Yeah, I think we have time for a couple of questions. If there's some mics up here, if any of you have a question you'd like to ask Daniel, and he'll also be around this afternoon in a variety of places, but I think we have time for a couple of questions before the 1 o'clock meetings start, if anybody wants to ask
questions, debate. There's a lot happening there that was sort of overwhelming you with things. Again, a lot of those elements can cross over between fields. So love to sort of hear any thoughts or questions. Yeah.
I'm very concerned about my privacy.
Sure.
I'm not sure that I'd want my children or my grandchildren to have a chip on their neck.
Right.
And as I read more and more things about internet being hacked, and I don't file my taxes online, I'm very concerned about this. And as a private pilot, I worry about my third-class medical failing someday.
Sure.
I'm not sure that I want this surveillance, but it does have value.
Well, we use our credit cards, and those get hacked. We haven't stopped using credit cards. I think we do need to pay a lot of attention to medical privacy, let people opt in, and use smarter ways to lock down our medical information, but also enable it to be connected in smart ways in a de-identified manner. But clearly, that's a huge issue. I mean, I could literally sequence your DNA from shaking your hand today, or I could potentially hack your smartphone and know where you've been. So I think there's a blend between being mindful of that and also enabling these technologies to take us forward. But it's a great point.
It's a great lecture. Thank you.
Thank you. All right. Well, I think you all have a 1 o'clock meeting, so thanks very much. Hope to see you in space or out of space.